Welcome everyone to our lesson on connecting to and setting up a network. Throughout this lesson we will learn about the TCP/IP protocols and standards Windows uses for networking, how to connect a computer to a network, and how to configure and secure a multifunction router on a local network. You'll hear all sorts of terms such as the 802.11 standards, Anycast addressing, different classes of networks such as A, B, and C, connection-oriented protocol, all kinds of different terms. You might hear DHCP, which stands for Dynamic Host Configuration Protocol. HTTP, you've probably seen that a lot, but you've never really looked into it much. That's Hypertext Transfer Protocol. So it'll be all kinds of new information or just a refresher of information for your learning on networks. So hopefully on your own studying as well as this brief tutorial, it'll help prepare you to assume total responsibility for supporting both wired and wireless networks in a SOHO, or what is known as a small office, home office environment. Let's now dive into a little bit about understanding TCP/IP and Windows networking. Now, when two computers communicate using a local network or the internet, communication happens at three different levels. It happens at the hardware level, the operating system level, and the application level. The first step in communication is one computer must find the other computer it wants to communicate with. The second step then is that both computers must agree on the method and rules for communication. We call these protocols. Then one computer takes on the role of making requests from the other computer. And a computer making a request from another is called the client, and the one answering that request is called the server. Now, most communication between computers on a network or the internet uses this model we call the client-server model. And you can get a look at that here in this little diagram below here, in which someone uses a web browser on their computer to request a web page from somewhere out in the old interweb through a web server. To handle this request, that client computer must first find the web server out there. The protocols for communication are then established, and then the request is made and answered by that server. Hardware, the operating system, and the applications on both computers are all involved in this communication process. Now, when your computer that you're using at home is connected to the internet through your internet service provider off somewhere in the distance, your computer and a computer out on the internet must be able to communicate with one another. Just as if you were making a phone call to someone, you have to be able to communicate with one another. Now, when the two devices communicate, they must use the same rules or protocols so that communication between the two makes sense to each. For almost all of our networks, including the internet, which is, as we talked about before, is a network in itself, the group or suite of protocols that are used for this communication is called the Transmission Control Protocol, Internet Protocol, or simply TCP/IP. Before any of that data is transmitted over a network, it's first broken up into segments, and each of these data segments is put into what's called a packet. The packet contains the data, and information in the beginning of the packet, this is called the IP header, identifies the type of data, where it came from, and where it's going to for delivery. If the data to be sent is much too large, it's first divided into several packets, each small enough to travel on our network. Now, part of the information that's included in the packet header is the address information to find the computer that is set to receive the packet for communication. The address information includes three levels. The address at the hardware level, this is called our MAC address. As we know, every network device has a MAC address. The next part is the address at the operating system level, called an IP address, and the address at the application level, which is called a port address. Let's take a deeper look at these levels. Let's use this figure here as just a way to break this down a little bit. Now, communication between two computers happens in layers. You can see how the communication starts with an application or a browser passing a request to the operating system, which passes the request to the network card, and then once it has reached the network card, then it goes onto the network. Now, once this request reaches the network card on the server side, so it goes down here, well, then it's going to do the opposite. Then that network card is going to pass on that request to the operating system, and then the operating system will pass it on to the application, which is our web server. So we'll talk a little bit more about those levels now. For those layers of network communication, layer 1, which is our hardware level. At the root level, communication obviously is our hardware. The hardware, or that physical connection, might be some type of wired or wireless, and it might use phone line or TV cable line. Now, for local wired or wireless networks, a network adapter, also called a network card, or some of us refer to it as a NIC, a network interface card, that's inside your computer. This is part of that physical network. Every network adapter has a 48-bit or 6-byte number hard-coded on the card by the manufacturer that we call the MAC address. And this number is written in hexadecimal. And this MAC, or Media Access Control address, can be found on any device. Part of that MAC address identifies the manufacturer that's responsible for making sure that no two network adapters out there have the same MAC address. And these MAC addresses are used to locate a computer on a local area network, or LAN. And a LAN, if you don't know, is simply a network bound by routers or other gateway type devices. And a router is just a device that manages traffic between two or more networks and can help the best path for traffic to get from one network or to another. You might have heard the word gateway or the gateway address. A gateway is any device or computer that network traffic can use to leave one network and then go to that other network. Now, layer 2 is that operating system level. Our operating systems use IP addresses, or Internet Protocol addresses, to find other computers on a network. Now, an IP address is either a 32-bit or a 128-bit string that is assigned to a network connection when the connection is first made. Now, an MAC address is only used to find a computer on the local network, but an IP address can be used to find a computer anywhere on the internet or on an internal network known as an intranet. And if you've never heard the term intranet, this is just a private network that uses TCP/IP protocols. A large enterprise might support an intranet that is made up of several various local networks. And when several local networks are tied together into a subsystem of a larger intranet, this group of small networks is called that subnetwork, and we usually just use the term subnet for this. And IP addresses are used to find computers on subnets, an internet, or the massive internet. And then our third level down here is our application level. Most applications used on the internet or a local network are client-server applications. Client applications such as IE, Google Chrome, or Outlook, those all communicate with server applications such as a web server or an email server. Each client and server application installed on a computer listens at a predetermined address that uniquely identifies the application on the computer. And this address is a number that's called a port number, port, or simply a port address. And there are several different ports that you need to learn. So remember that port number uniquely identifies a computer application.